Hello, everyone, and welcome to today's webinar, Unleashing the Power of AI in Logistics. I'm Wade Roush. I'm a business and technology journalist based in Santa Fe, New Mexico, and I'll be moderating today's discussion. Okay, now, I'd like to walk you through our topic for today and then introduce you to our speakers. The plan is to talk about one of the areas of business and commerce that is gradually, but only gradually, being transformed by artificial intelligence in both its traditional form and its newer generative forms. Now, logistics, obviously, is all about moving things around in the real world. So often these are big and expensive things, and you need to get them to the right place urgently. That is a service that requires speed, accuracy, and repeatability. And so it's not a business where you can afford the sloppy reasoning or casual plagiarism that you've probably encountered in a lot of today's generative AI systems. And it's definitely not a realm where problems like confabulation and hallucination are okay. So it's important to remember that we're only a few years into the generative AI revolution, and it's going to take time to figure out how to deploy generative AI safely and productively in areas like logistics. Overall, though, logistics is an interesting case study because it's one of those realms of real-world business operations where mistakes and misinterpretations really aren't acceptable. So it'll be instructive to see how this next generation of AI tools gets implemented. And one area where AI is a clear boon is in modeling the physical world using real-world data and then running predictive simulations that can help with decision-making around logistics. And that is part of what our speakers are going to talk about today. So now I want to bring them on and introduce them. First, I want you to meet Lior Ron. Lior is the founder and CEO of Uber Freight, an enterprise technology company powering intelligent logistics. Over the past decade, Lior has been at the helm of some of the most exciting technological developments in logistics. Along with his team at Uber Freight, he's pioneered the application of AI and machine learning to advance transportation technology and optimize the movement of goods across one of the world's most comprehensive logistics networks with more than $18 billion in freight under management. Lior received a bachelor's and master's degrees in computer science from the Israel Institute of Technology and an MBA from Stanford. He began his career as the CTO for Israeli Army Intelligence before joining Google in 2007, where he helped to scale Google Maps from 10 million users up to 1 billion users. In 2016, Lior co-founded Otto, a self-driving truck company that was later acquired by Uber and has grown into what's now Uber Freight. Now I'd also like you to meet Chris Kaplis. Chris is a senior research scientist at MIT and serves as the executive director of the MIT Center for Transportation and Logistics, where he oversees the research, education, and corporate outreach programs. Chris created and leads the MIT-X MicroMasters program in supply chain management, which was the first online credential ever offered at MIT. He's also the founder of the MIT Freight Lab. That's a research initiative that focuses on improving the way freight transportation is designed, procured, and managed. Outside of MIT, Chris is the chief scientist for DAT Freight and Analytics. And in that role, he pioneered the development of the Freight Market Intelligence Consortium. Chris got a PhD in transportation and logistics systems from MIT, a master's degree in civil engineering from UT Austin, and a bachelor's degree in civil engineering from the Virginia Military Institute. Okay, so Chris, Lior, it's great to have you both here. Thanks for joining us. Our plan today is I'm going to turn things over to Chris, who's going to talk a little bit about the differences between traditional and generative AI as they apply to logistics. And then Lior will walk us through some of the recent progress in generative AI. And then they'll move forward with a discussion about how AI in all of its various forms could and should be adopted in logistics and what the possibilities and the limitations are. And I may jump in with questions from time to time. About 2/3 of the way through the hour, as I said before, we'll wrap up the formal presentation and we'll go to questions from you in the audience. Okay, so Chris or Lior, take it away, please.
Great. So next slide, please. So artificial intelligence, you'd have to be living under a rock to not have heard this and played around with it. But what we see is it's cited by many. If you go to any conference, any technology or supply chain conference, everyone is doing AI. So it's cited by many people, understood by very few. On the left is the initial definition by the really founder of AI, John McCarthy, back in 1955. So that was over, 70 years ago almost. And it's a science and engineer of making intelligent machines. But on the right, I have Daniela Russo's definition, which is more nuanced. She's kind of the leading light here at MIT in AI. But what we see is that while AI is everywhere, it means whatever you want it to mean. It's very fuzzy. Some people say it's only this very specific methodology. Other people say it's AI if you use math, right? And so there's this wide spectrum. And so what I'd like to think about it for AI is that it's a moving target. It's not sitting still. It's aspirational, because what they considered AI 30 years ago, even 20 years ago, is not considered, cutting edge AI anymore. So it's always that thing that exceeds our grasp. And so I think it's very helpful to think in context of the different tools that we have as analysts. So next slide, please. And so when you look at this, first build, So you have three big buckets of tools that you have out there. What's known as traditional AI or machine learning, generative AI, which is kind of the newest thing out there right now that's been coming out for the last 18 months in the public, and then operations research. So for traditional AI and machine learning, ML, these are the things that we see a lot of: linear regression, k-means clustering, reinforcement learning, neural networks. That was the cutting edge of AI. Now it's considered traditional. These are tools that are widely used in practice. Then you come to generative AI, which is the newest thing. And what these really are transformer models, things that are able to use large language models to take something in context, summarize that, and really apply some amazing techniques to generate new content or something that's between the data that they was trained on. But the final thing that's the grandfather of these tools, that's the most widely used, is OR, operations research. This is where linear programming, dynamic programming, network models, heuristics, we live off OR. And so sometimes it's forgotten in the discussion. And what I'll show in a little while, I'll show that it fits in. These are all complementary. No one's going to do everything in Gen I. No one's going to do everything in machine learning or everything in OR. They complement each other. And I'll talk about an example where you see how they interact with each other, because they all have strengths. They all have weaknesses. They have pros and cons. And so with that, I'm going to turn it over to Lior.
Thank you, Chris. Excited to join this wonderful audience and talk a bit, switching gears a bit, to talk about a third of what Chris just talked about, which is the future, Gen AI. And if we just zoom out for a second and try to have an intuition for why this is going to be so transformative and why it opens up so opportunities, some of it just starts with simple math and physics. We all, as human beings, have about 80 to 90 billion neurons or processing units in our brain that can do stuff: learn, reason, read, create content. If you look at those transformers, those new machines, those large language models that are learning, and every one of those units of learning and reasoning is essentially a transformer. If you look at the new OpenAI or large language models, well, those have almost 2 trillion parameters. So 20x more than what an average human brain will have. And we're just getting going. Those numbers are going to double and triple every couple of years. So when you have just a sheer amount of processing power coupled with the ability to access every bit of data ever created, you have just created a machine that can learn faster and better for those specific tasks. And we're going to talk about a few of those examples that are perfect for that large language models. So it starts with just sort of the basics, physics of it all. And if you move to the next slide, the amount of progress and the fact that we are now living in a fully connected world that is a precondition for AI to flourish are basically paving the way for the fastest adoption cycle of any technology we have ever witnessed. And to put it a bit in context, we've put here a smartphone next to the internet, next to AI. AI and Gen AI, LLMs are already being used by over 1 billion people less than 2-3 years after introducing that, and we're just getting started. The fact that we now have systems, data, and ability to do all of that in a cloud, coupled with the amount of capital and innovation going into the field, means the adoption vector here is going to be much faster than any technology we have ever seen. And I'm putting it here to allow all of us to just, and that's the reason everybody's joining the seminar, to really be open and stay very close for what does it mean for us as society and what does it mean for us in logistics. So next slide, I think it's fair to say that we all agree that AI will fundamentally transform logistics. The extent of the possibilities, the sheer amount of processing, the capabilities, and the fact that in the end of the day, logistics is ripe for AI in terms of really optimizing the network, optimizing logistics, improving the overall supply chain. Those are problems that AI is a very good fit for. And we're excited in the next 20-30 minutes to explore some of those possibilities and some of those initial ramifications.
A gap. It's filling a hole in those other techniques that we had never been able to solve before. So the logistics is so interesting because it combines hardcore math, but also there are people involved. And so this kind of bridges that gap and it allows you to kind of connect those two things. So I think logistics is ripe. Transportation especially is ripe for transformation using all these new AI tools.
Now, to remind us on the next slide, some of the challenges and opportunities, the logistics industry, for those here on the webinar out of the industry, is ripe with challenges and opportunities for the betterment through AI, whether it's the nature of the fragmented supply chain and the need to connect that network to optimize and drive a better outcome, whether it's the constant volatility of prices and service, and as we've all witnessed in COVID, the availability of goods, whether it's growing safety concerns, whether it's on the road or on digital fraud, and whether it's the huge climate footprint transportation and trucking and freight has. All of those are fundamental challenges that are just increasing as we all want to click a button and just have stuff delivered to us. The pressure on the system keeps growing. And we fundamentally believe AI can play a big role in answering all of those, or at least helping answer all of those challenges the industry is facing over the next couple of years. And to start, to move on the transformation, the precondition for any type of AI, machine learning, Gen AI, operation research, is data. So on the next slide, it's really what we've been doing at Uber Freight for the last 8 years, and what I've been doing at Google Maps for a decade before, is creating that digital representation of the physical universe, of the physical supply chain, and digitize all of those assets, where every truck is at, where every ship is at, where every warehouse, and how to connect with that warehouse, where every shipper needs connectivity to their ERP system, where every appointment scheduled in every warehouse in the United States. The precondition for any optimization on top is having a robust, deep, and accurate, with the emphasis on accurate, slice of data. Then the fun begins. When we start connecting the supply chain with the speed of light, not with the speed of people, when we start to unfragment the huge fragmentation by bringing everyone to a network and connect them digitally, then we can unleash the computers and start finding opportunities because we have the right digital representation. We've been having a lot of fun with that mission for the last 8 years, and now at Uber Freight, we manage $18 billion of freight under management, meaning we have digitized and are touching a big subset of the entire North America supply chain, and we have enough scale to start doing interesting stuff on top. Let's move to the next slide and talk about some of the appetizer of the interesting stuff that we have been done with traditional machine learning before the advancement of Gen AI. So one example on the left is basically pioneering sort of upfront guaranteed pricing for trucking and for freight. So the same thing you'll expect out of your Uber ride, knowing the price upfront, or from your Amazon good, or from your Airbnb booking. We basically, instead of like having a lot of friction and unknown on the pricing, using machine learning, we're looking at hundreds of different time parameters, geo parameters, historical parameters, and coming up with what we think will be an upfront price for a truck move even a week from today. And that's never a 100% accurate model, but with machine learning, we've been able to make it accurate enough to introduce a marketplace that is now removed of all the friction of guessing, getting back and forth, and trying to estimate the price of trucking. Another example will be, now that everything, the network is connected, we have 2 million truck drivers on the Uber Freight network using the Uber Freight app. We know what they like, where they want to go, what kind of lanes they want to haul, which days of the week, what type of equipment. We also know that on $18 billion of shipper preferences, now it's a fun matching problem of assigning the right shipping opportunity to the right truck driver at the right price, at the right time, from the right shipper. And imagine the compute power. And maybe last example, then some fun begins. Then you can start being an algo dispatcher for those truck drivers using sophisticated machine learning versus a truck driver moving 30% empty on average, which leads to a huge unnecessary carbon footprint. If you can algorithmically design the perfect route for that truck driver, we've been able to remove half of those empty miles. So now an Uber Freight driver using the Uber Freight app can now only drive maybe 10 to 15% empty versus going back empty from Chicago to LA. We can find him a perfect route from Chicago to Arizona, and then maybe through Texas to Arizona, and then to LA, and really minimize empty miles, which means money in their pocket. To maybe go deeper on a concrete case study, I'll hand it back to Chris to talk about some fun stuff MIT has done.
Yeah, so nothing at the scale that you're doing at Uber Freight, but we're doing some cutting edge stuff. So next slide, please. This is work based by Dr. Matthias Winkenbach, and it's actually part of his lab that's called the Integrated Logistics Systems Lab, also with his CAVE lab as well. And that's another lab up here at CTL, which is at MIT. Next slide, please. The problem I want to talk about is known as the vehicle routing problem. This is a classic problem. It's the idea is to go from one location and visit a number of stops, whether to pick up or drop off, whatever, and then come back and return home. It's called the traveling salesman problem. There's many, many flavors to it. It can be capacitated, time windows, all these different complications. But historically, you have a method, it's usually operations research, that tries to minimize the time, the cost, the distance, or some combination of those three things. And there are entire courses dedicated to this. There are disciplines dedicated to the routing problem. It's one of those easy to understand but hard to master problems. And what's interesting, though, is the difference between humans and computers. Humans are really good at seeing this intuitively. We can solve small problems faster than a computer because we can see everything all at once. Most computer applications have to go stop by detailed, and they have to step through the problem. Now, the challenge is once it gets to a certain scale, humans fail. We can't see it. So the challenge is, how do we scale this to larger problems, bigger problems? Because it's well known to be an NP hard problem, which means it gets really hard really fast as you get larger size. The other challenge is, how do you capture non-traditional goals or measures of what a good route is? Because as we all know, the data can't contain everything. You want to contain it for the model, but the model can't consider everything. It might not know that you can't park at a certain spot, but the driver knows. And so this is one of the challenges with traditional techniques, is that it can't take those things into consideration rather. The driver might know, though. So the challenge here is a classic VRP, vehicle routing problem, but there's some complications to it. Next slide, please. So what Matthias and his team has done is combined the three techniques that I talked about at the beginning, classic OR, right, which is, it really works well in a lot of situations, with some standard machine learning, and then combining that with AI. And so what we're finding is that they're complementary methods. They don't have to replace each other. And so what we see is initially that AI is taking a subordinate role, and it's more of a complementary problem. But as we advance through, we're starting to see it take more of a primary role. And eventually we'd like to see the AI take over and be able to solve larger parts of that problem. And let me give you an example of why that makes sense. So next slide, please. When you think of this, large language models, we think of grammar, we think of sentences and words, and we think of the simplest example is on your phone, where it tells you what the probability of the next word that you'll want to put in your text, for example. Well, you can think of a route, right, which is a tour of stops put together, as a sentence. And you can think of each stop as a word. And so what you can do is you can train on what drivers are actually doing, and that can give you an idea of what is a good combination, what is a good string of words in that sentence. And so thinking of it that way is totally the opposite of the way of thinking classic OR methods, which has a much more rigorous approach. And one of the challenge with the classic OR approaches is that every time you introduce a complication, like different time windows, or you have kind of different size streets, different capacities, the algorithm needs to be tweaked, right? So there's really specialized algorithms for every situation. So what large language models are able to do with Gen AI is to be able to generalize that. And it doesn't matter. You don't need a new algorithm. So what we've done in this, we found in these tests that we are exceeding classic OR methods for these larger problems, and it has some other managerial benefits. So next slide, please. And there's 4 big ones. The first one is that these models, you train them on data, right? And then you give it test data, and we're finding that it outperforms its training data. This is huge. This means you don't need to have a perfect set of routes that have been supervised and vetted by drivers. You can train on really bad data, or the stuff you've actually been doing, and it'll outperform that. So this is a really nice time-saving thing, because it means you don't need to generate special data. The second thing is, by being trained continuously, better routing policies will be learned automatically. If a policy gets shifted, the model will just pick up on that, as opposed to having a new specialty algorithm for that. The third point, these models tend to eliminate the need for those special algorithms I was talking about, especially as you get a larger size or different characteristics. This accommodates that. And finally, the last thing is kind of ties to that, is these models generalize to unseen problems. And so what we're doing up here at MIT, Matthias and his team, is applying this to a large data sets and capturing new things that weren't considered before. So in summary, what machine learning and AI is doing, especially generative AI, which we were surprised at, is taking this large language model approach and solving what has been pretty well solved by OR, but solving it in a different way, faster, more completely, and also to non-traditional objective functions. In other words, good routes that their driver considers, not just minimizing distance. And so we're seeing a lot of opportunity here, and the exploration and research is continuing. So a lot of good stuff coming up here at MIT, but I'll turn it back to you, Lior, to talk about stuff that you're doing at Uber Freight.
Thanks, Chris. So Gen AI is great for algorithmic optimization, as Chris just touched on. Of course, it's great for a bunch of backend automation and processes, whether it's support or manual mundane tasks or whatnot. Next slide. I think what we have been exploring for the last year is a slew of algorithmic of how can we make the backend better, a slew of programming improvement. How can we make our engineering more productive by having a co-pilot for coding? A slew of operational improvement. How can we make our support agents better and grow them wings with the power of LLM? But what we think is one of the most interesting implementations and possibilities for the future is what if we take the power of LLM and Gen AI and actually hand it over to the decision makers and unleash LLM and Gen AI for supply chain professionals as a tool to essentially make better decisions on their supply chain. And next slide, that's actually what we've been doing for the past year. We have developed something we call Insights AI, which is essentially a co-pilot for logistics, looking at all the data, all that $18 billion of freight under management. And it's specifically, if you were like, and those some of our customers, like a Nike, a Colgate, a Kellogg, a Danone, specifically looking at their data and offering those professionals the ability to understand, to query, to get instant answer on anything they want to know about their supply chain, and take a process that takes days, if not weeks, of manual labor and basically unleash that to those supply chain professionals. Next slide. I think the approach is really looking at all the data we have available in front of us, customer data, cost and need data, the $18 billion of TMS data I've mentioned, historical data, market rates, anything we can have access to, and develop, I would say, a logistics LLM, a large language model that fully understands the context, how those things relate to each other, and can reason on top of that and summarize that and then make it available for those decision makers. Let's see that in action. If you can move to the next slide. And we'll let the animation go. So this is Insights AI that's live in production today with some initial customers. And I can just type a natural language question: which origin points are responsible for my highest spend to date? I don't need to look at a Tableau or like open some Excel sheet or like shoot an email for the analyst. I instantly get an answer. The LLM understood what I'm trying to ask, and I'm getting all of those destinations, including the cost, the service, and everything that I want to know about those origins and destinations. So now I can start asking follow-up questions. Okay, thank you. I have some issue here at origin 9349. What's happening here? Who are the carriers that are like shipping stuff from that destination? Tell me a bit about why they have an issue. Okay, those are all the carriers, all the trucking companies that are moving stuff, moving goods from that facility. And this is their on-time delivery percentage. This is how good or not good they are. And not only giving you the chart, but also giving you a bunch of supplementary charts and a bunch of text explanation, giving you some insight on what are you actually seeing in some of the early reasoning we can do about those carriers. Then I can dive even deeper. Okay, I understand the carriers, I understand everything, but like show me what's happening last week by a bunch of slices, by mode type, by shipment count. I want to really sort of understand where do I have any cost leakage. So now I know, okay, by truckload, that's my cost. By less than truckload, that's the cost. That's my rate per mile. That's how much shipments I've done. And I think you sort of get the hang of it. Basically, end-to-end ability to ask and get instant answers on anything and everything in my supply chain. And not only specific one, but open-ended one. Just tell me, LLM, where do I overspend? And I'll save you all the video goes another 5 minutes. Then I can ask, why do I overspend? Hey, LLM, do you have an hypothesis? Why do I overspend? And on and on and on and on. So imagine basically collapsing a month-long hey, dear analyst, can you make me a presentation with a nice graph? Let's go and discuss that and then see a follow-up after 2 weeks, just collapsing all of that to an instant feedback loop, back and forth, me, the decision maker, and my supply chain, where I can really touch the data in a very intimate and very instant way. We have deployed it successfully in the last few months. We have a waiting list now of 200, I would say, Fortune 1000 shippers waiting to be onboarded. Actually, funnily enough, one of the challenges is human language. When Walmart say on-time delivery, and a Costco says on-time delivery, and a P&G or Amazon says on-time delivery, they mean different stuff. So we had to develop basically a model, a shipper-based model that really understands when I say those acronyms in my context, enterprise context, what do I actually mean? So we can sort of translate and have all the information robust back and forth. Maybe I'll show you a bit of what's going on behind the scenes just quickly. Next slide. In the end of the day, as Chris mentioned, this is basically an orchestration of LLM agents. Each one of them is very good at what they're doing, and we're basically allowing them to, so you have an agent that is supposed to understand your question. You saw the performance, I want to type a natural language question, so then we want to understand that, we want to tag, we want to annotate, we want to, first and foremost, understand what the heck are you asking. Then there's agents that are good about data retrieval. They understand all the data sources, and they're very good at going to the database versus going to that Excel repository versus going to a ERP system versus going to market data and really build domain-specific knowledge of those data sources. Then we have agents that are synthesizing that data together. And then finally, we have agents that does synthesizes help us choose which data source do we believe, which are we going to give more ranking to, how we're going to intuit and reason sort of the answer for that. And then finally, you have agents that are bring all of that together back as a natural language with natural explanation of why have we derived that answer in a language we can understand, and give that extra context and be guarding against hallucination, which is the machine sort of going off the rail and intuiting stuff that is untrue. Next slide just shows you sort of a topology of that as an example. Orchestration of agents. Every agent are very, very good at what they're doing. And the beauty of this, it basically allows you to build a library, basically a platform with hundreds or thousands of different agents. So then for every GenAI workflow in your business, it's really taking those domain-specific agents and connecting them in different ways, like Lego pieces, to be able to derive sort of a new use case or a new implementation for what you're trying to accomplish. Okay, so that's a bit of an example of the highest degree of trust, right? This is 2 VPs to chief supply chain officers on their most intimate and important machine, business critical data. I wanted to give maybe just one more example of the possibilities and the realities of where GenAI is used in logistics. So what if that GenAI can be unleashed on the physical world and actually become your driving instructor? So next slide. And I think what you're seeing here, and hopefully you see that, is, sorry, I lost the window for a second. I think what you see here is GenAI being your driver instructor. This is a self-driving startup named Waabi. And what you see here is the same way that data is produced by LLM to generate text on your favorite text application, or generate audio, or generate video, or whatnot. This is GenAI unleashed on the physical world and creating endless permutation of what driving looks like in the real world. So here on the right, on the left is a computer-generated image. Those cars are actually virtual, they're not real. On the right, you have the physical world. And what you can see here, I can take the scene on the right and start adding objects, cars, cones, emergency vehicle, play with the roads, play with the angle of the sun, introduce the deer or the nylon bag or the wheelchair, and start creating infinite amount of permutations. And after I've done that, then I can start testing that in a simulator to be able to learn how to drive much faster, and then compare those results on the virtual simulator with the results on my physical driving to see how good I am compared to human driving. And that's an approach that allows to accelerate self-driving development by an order of 10 to 100x, because instead of driving every one of those permutations and not being able to test the long tail of instances that will be required to go to safe driverless operation, you can do that all now at scale through the machine. And we are seeing phenomenal results from that startup and a slew of other startups essentially leading the path on GenAI for self-driving. And we are at this point 6 to 12 months away from the first ever driverless commercial operation in Texas by Waabi, Aurora, and a few of those other self-driving companies using techniques like that. So that's a bit of two extreme examples of the power of GenAI and what that can accomplish for all of us in logistics. And I'll hand it back to Chris to talk a bit about some other topics.
It's intoxicating. Oops. I'm unmuted. Yes. Okay. It's in next slide. So it's intoxicating to talk about the technology, what it can achieve, but I think it can do nothing without the people involved. And so what I see that this is really doing is helping people do their jobs better. It's really replacing a lot of tasks that are done. It's not quite replacing entire jobs yet. There's been some interesting talk about that. But what I see AI doing is there's a continuum from things that we do, completely manual tasks, all the way to completely automated. And what Gen AI is doing is moving that boundary a little more closer to what we can automate that we couldn't do before. Whether it's what Lior showed about summarizing a report that used to be a very manual process. You'd have a junior analyst go in and collect these things and make a PowerPoint slide. Well, that's now been automated. So that task now has been moved up. And so the mundane piece of putting things together is being replaced now. And I have more time to say, okay, what does it mean? What do I do? It's the action. So what I view Gen AI doing is helping, using all this massive data, helping people do their jobs and do the interesting jobs a little more, a little better, being able to spend more time there. And I think with that, Lior, I think it goes back to you. Last slide.
Yeah, I'll quickly summarize. You must be asking yourself, what am I going to do with all this information, and how can I start my AI and Gen AI journey in my organization? And here's some quick takeaways and best practices we've learned working on this in the last couple of years at Uber Freight. It starts with education. This is what we're doing in this seminar. Really embed yourself, immerse yourself, understand the opportunities, and not just you. Educate your leadership team, educate your organization, invest in understanding the capabilities so you can start actually building the road for where can those be manifested. Next, once you've educated, really invest in identifying change agents. Who are the change agents in the organization that can be on the journey with you and can advocate for those implementations, understand the capabilities, bring stakeholders to the journey, because it's going to be a long road, and it's going to be a lot of up and down, and we all need to have a lot of patience as we explore this new technology. The next one is really building together. you cannot be successful if it's only the technology organization, if it's only the operation, if it's only sales. You need everyone. It takes a village to really understand how to marry that technology with the operational need, with the business need. Every one of those ideas that I showed you and the 50 other Gen AI projects we're doing at Uber Freight, by definition, have a tiger team of an engineer, a product manager, a data scientist, but also an operation expert, a commercial expert, a support expert, so we can build that together versus developing stuff and throwing it over the wall and hoping it works. And the best ideas usually actually come from the business side because they actually understand what needs to be solved. And finally, in terms of last best practice, really, you need to be rapid experimentation, try stuff and fail fast because you really want to understand what works and what doesn't work, but have patience. It's going to be a long journey. We have been on a path of, like, we had a hackathon, combining those teams. We had 50 ideas out of that. We tried all 50, like 40 of them miserably failed. 10 kind of succeeded with a bunch of ups and downs. You need to have patience, and that patience allow you to really achieve that in the end. With that, let's hand it back to Wade and do some questions.
Yeah. Thank you, Lior. Thank you, Chris. So we are going to move into the interactive part of the webinar, and we have a bunch of great questions coming in. Chris, I wanted to jump back to that map you showed. Having lived in Cambridge and Boston for a ton of years, I know that there's no such thing as a most efficient route between all those points that you guys were connecting in Cambridge and Boston. But I'm glad to hear that generative AI is creating a computationally plausible way to solve these problems that doesn't blow up on you.
Right.
Okay, so we do have a question coming in about one thing that might actually blow up on you with generative AI, and that's the electricity costs. So can you both speak to the sort of the scale of the models that you need for this kind of work? What models are you using, and how do you account for the costs of the actual AI cycles, including electricity and the environmental impact?
I'll let Lior do that because we're doing it on a smaller scale for this, but it is a major issue. But the thing is, the energy requirements are going to only increase. And so, the grid is a major obstacle, both for what we're talking about here, but also for EVs that we're trying to do. So the electrical grid is its own issue that's probably way beyond the scope of this. But yes, it is a large context. But I'll let Lior hit that one out of the park.
Yeah, I'll say a few things. First of all, really important to understand the architecture of LLMs. Most of the energy processing cycles is taken for training and to build those large language models. Those will be done by a handful of companies, and they can concentrate their vast capital and resources on doing that, and they will need to do that more and more efficiently. And yes, the compute power, the resources to do that will go exponentially over time, but that's only on the training stuff. On the reasoning, that's the whole beauty of LLM. You don't need to spend a lot of those cycles. It's relatively low processing. You synthesize and with reasoning on top of that, it's relatively low spend. That's one. Second, in every one of those transformations, you can't only look at one side without looking at the other. On one end, you are spending a compute cycles to train a model, and you are saving a lot of other back office processes, other compute resources, making the whole system more optimized. So if you can actually approximate the total energy spend, what you spend and what you save, I think that's a more balanced picture. The last thing I would say on cost weight is initially, I think the experimentation is done with relatively a loose model of cost. I think you really want to understand the product market fit and where those things are best. And then you have a lot of time to optimize your cost at scale. And that's what we're doing now. We've done rapid iteration, got something we think is working, and now the team is optimize the heck out of that cost-wise so we can actually scale that. That's all that I would say.
Okay.
And the efficiency of LLMs have dramatically, even over the last 18 months, have gotten much more efficient because, as Lior said, that's the focus now, is to make it more efficient. So I think it's a short-term growing pain problem.
Right. We can't stay on this trajectory much longer. It's just not plausible. in terms of energy cost. All right, we have a question about sort of the pace of adoption of generative AI in logistics. So it sounded to me, Lior, as if the current right now applications of generative AI have to do with back office functions, to put it bluntly. Like how do you query your data analytics system in a more natural language kind of way? And that's 1, 2, or 3 steps removed from actual sort of like self-driving type applications, which seem like they are still, as you said, maybe 6 to 12 months away from implementation. And so how do you think about sort of managing the risks of implementation as you get closer to real world applications of generative AI? And, you want to be sure you're guarding against questions like biased data or security or fraud, those kinds of things. Like, what's the right pace to roll these things out in when the rubber literally meets the road?
Look, like every new technology, this is going to be, I think, a society-changing technology. As such, I don't think you can slow down the pace of experimentation, capital, and use case exploration coming out of that. And as always, in every technology transformation, there's going to be the people that have invest and do the foresight and will create some advantage, and folks that will be left somewhat behind. Now, that being said, I think it's important to talk about 2 different use cases. One, and that's the primary one today, regardless if it's back office or front office, we, the people, are still in the center. The technology augments us, allows us to grow wings. It's bicycle for the mind. We can be more efficient, more effective. We can improve our quality of decisioning, but we are still making those decisions. And as such, I think this is all pure goodness and relatively low risk. You still have a human in the loop, and that human is looking at a bunch of crappy data today to make a bunch of crappy decisions. So in the future, they will look in less crappy data to make less crappy decisions. I think as long as you have a human in the loop with the proper training, with the proper context setting, with explaining the issues and the limitations behind the technology, with responsible development, I think that's sort of in a relatively straight way. The other type of use case is self-driving, as an example, where you do take the human out of the loop. Or, I mean, Chris mentioned machine learning optimization, where, yeah, the algo is just like unleashed, and like you don't have a person in between. On that, you need to, like any other technology, pass through rigorous testing. Mm-hmm. For the algo stuff, we do an algo change on automatic pricing. We have like 2 months of A/B testing on like 15 different experiments to validate the quality of that change. For self-driving, all of those self-driving companies need to pass a publicly peer-reviewed safety case that shows, without any doubt, almost mathematically proven, that the technology is safer than the average or even some of the best human driving, and need to pass through all the sort of right regulatory scrutiny as well. So I think it's important to understand if it's human in the loop or not human in the loop, and have the proper checks and balances for both.
Mm-hmm. I think every organization that we work with hundreds of companies up here is trying this, and they're doing it like every new technology. You pilot first, right? You're doing a bunch of pilots. Some work, some don't. Lior mentioned 50 different things that came out of a hackathon. But then when you're implementing in the back office is so much safer, right? It's less risk, right? Until you put it into customer faces. So I think it's following the same path that every other new technology is being piloted on. There's a lot more initiative here on it because it's so easy to start the process, and there's such a demand for it from top down to do something in generative AI. But I think it's following the same path as most other new technology adoptions.
Okay, we have a bunch of other interesting questions coming in, and a lot of them had to do with sort of how you move this into the real world. So here's a question about how you would expand some of these applications beyond the continental United States. So we have pretty good digitized information about roads and ports and borders and so forth for the United States. How do you, what recommendations might you have for people in Latin America, for example, for applying some of these logistics AI ideas outside of the places where we have perfect map information? And related to that, we also have a question about, can you actually kind of account in advance for some of the real world hazards, risks, situations that people might run into along an actual route. So how do you build in? So those are two questions. I'm kind of like merging them, but how would you respond?
All of those approaches are generalizable across geo, across domain. There's nothing here country specific. The biggest delta, to your point, is data. So my advice for South America, for even Europe at times, for any other developing markets, is data. As long as we invest in data, and as long as we build up that digital infrastructure and get the right data, get the right connectivity, get the right understanding of the supply chain, investing in ERP systems, investing in TMS, transportation management systems, investing in digitizing the flow of freight, then you can do a lot of fun stuff on top, and it should be really, it will be very generalizable. It just then it needs the right capital and focus. So my advice is really focus on data first, make sure that's in order, and then I think things will be very generalizable. On your second, go ahead, Chris. No, so on the second piece on hazards. Sorry, what's the question again, Wade? How do you account for hazards on the road?
Yeah.
So you do pre-processing, obviously, but most of the intuition and what you need to decide are real-time decisions based on what you see on the road. So don't get me wrong. Like you do a lot of like to make sure that's a complicated construction zone. But at the end of the day, I'm a truck. I'm driving on Dallas to Houston. I see a construction zone. I need to make based on my learning, like we have need to based on our learning as a driver and experience. What do I do to navigate through the construction zone? So it requires real-time mapping. It requires a long-term laser detector LiDAR that can see 2 kilometers into the highway. It requires sophisticated, like 16 plus cameras that are fault tolerant in case half of them, for some reason, completely malfunction. And it requires real-time processing to be able to make those safe decisions, including at times of trucks, like a sort of emergency maneuver to stop on the side of the highway safely if you can't figure out exactly what to do if there's an object that you cannot overcome.
Right.
So the real-time nature is very real. And to give another plug for LLM also helps you make better decisions in real time because of the generative and reasoning power of those language models.
And I assume that data that the trucks are gathering is feeding right back into the model. So the next truck that comes along knows about a hazard that the previous truck just detected. Okay. So it's going to cost money to build up these databases. And we have a question about sort of what's a reasonable way to think about the sort of time to payoff or a break even for these kinds of investments?
Great question. In the end of the technology side, every decision is a business decision. And I think you need to understand the payoff, the ROI. So I'll suggest a few things. One is, that's what I meant with all of those best practices, build together, rapid experimentation in the energy into the highest ROI, maybe lowest risk, not inherently, but highest ROI area of your business. How do you get it when the opportunities are? And even after that, you do that with rapid experimentation, so you can maintain your cost super low and only invest in stuff you know is actually going to have an ROI and you think you have a path to do. Now, some organizations have the capabilities, like in Uber Freight, we have like a plethora of like hundreds of machine learning scientists and data science, we can do that in-house. Some organization will choose to tap into expertise, whether it's Chris advising them on their path to AI in their company or buying a product from us. Some companies will choose to tap into external expertise, and that's perfectly fine as well as a way to basically lower the amount of investment. And then the ROI, it really depends on the use case and what you're trying to solve. Some of those
Yeah, so Lior's connection is quite
Things
choppy.
Okay, so on the, can you hear me now? I was just saying,
Lior, I'm going to ask you
I'll
to
hand it
stop, because your connection is so bad that we've actually, okay, you're back on stage now. Great. Yeah, so actually, let's just move on to maybe a lightning round final question, and then wrap up. I just wanted to ask you if there's one big takeaway that you think our audience should go home with, sort of about how they might think about starting to implement both traditional and generative AI in their own organizations. Sort of like, what are the one or two things you'd like to send people home with today? And Chris, do you want to start?
Yeah, just experiment. Just experiment. There's so many options out there. It's not just ChatGPT. There's dozens of different models out there. And so start playing with that, but then start with a problem. So you're going to play around to see what it can and can't do. But the projects that I see fail are ones where we're going, I've got my hammer, and I'm looking for a problem. So think of the problems that you have, and they will naturally fall into one of those three buckets that I talked about. There are a lot of problems out there that OR will work just really well, or machine learning, regression can work really well. But those things in the middle, that they, start experimenting with Gen AI. Get your people used to experimenting and getting to understand it. That's my big takeaway.
Is there any organizations that's too small to start thinking about this, or do you have to be a certain size before it starts to make sense to implement?
You have to have at least one employee yourself, right? I mean, this is, in fact, the benefit, in my opinion, is going to accrue to the smaller organizations. Just like if you look at general IQ, AI is going to probably improve the lower IQ people to come up further than the higher IQ because there's less room to go. So a bigger company can put more resources on it. AI is such a huge Goliath to have it in your back pocket. It'll really help a smaller organization much more than a large organization, in my opinion.
Okay, thank you. So, Chris, thanks. And I apologize to the audience for the technical problems we were having with Lior's connection. But we had him for most of the hour, so that was great.
Yeah.
Okay, thanks again to Chris and Lior. Thank you to our audience today for your attention and for all these great questions. I wish I could have gotten to more of them, but we're just about out of time here. And that's it. I want to thank today's content sponsor, Uber Freight, for making today's webinar possible. Thank you, everyone. It's been a pleasure talking with our guests, and have a great day. So everybody take care.